Okay, so now we're in the second half of experiment number 2, and we had 34 degrees in our last one when we tried this combination of ingredients. And so we have to try to lower that temperature. And we know that carbon chloride creates exothermic, so it heats up the water. Baking soda decreases it with an endothermic reaction, so that decreases the water. So we got to find the right combination between an exothermic and an endothermic product in order to get our temperature range within 28 degrees to 32 degrees. So we're just 2 degrees too high. So I'm going to adjust one variable. I'm going to adjust the calcium chloride. So we're going to put 1/4 teaspoon calcium chloride in, 1/8 of a teaspoon of baking soda in, and do it again. Okay, I have 1/4 teaspoon of calcium chloride, and I'm going to put 1/8 of a teaspoon of baking soda in. Mix those up. And read my initial temperature is at 23 degrees, so I'm going to mark that in my page. 23 degrees for my initial on my water. I'm going to add my ingredients and mix them again and see what I can come up with. Okay, I have another reaction, which is good, and I'm going to look to see what's happening. So my thermometer is going up, and we'll see where it stops. Once my bubbles are released, then I know my gas is already produced, and we'll talk about that in a second, what the gas is. Okay, it is rising, and it is continuing to rise. So we will sit and watch. Okay, it has stopped, and it is at 30 degrees Celsius. So that is within my range. Now, I did it once. To verify it, though, I have to do it at least 2 more times. So I'm going to put it at least 1 more time for your paper, and I'll do it a 3rd time to make sure it works. Okay, this is the second experiment, second trial. So I'm going to go ahead and put 1/8 of a teaspoon of calcium chloride into my other cup, 1/8 of a teaspoon of baking soda. Mix those two together and then put them into my cup. I am measuring, my initial temperature is 23 degrees Celsius. Go ahead and put those in, mix them up, and watch my reaction and see if I get the same temperature as I got last time, which was 30 degrees. So we're going to leave it down there. Okay, we're still getting bubbles, so I'll wait. And we are right at 30 degrees again. We'll do it one more time. Okay, now we're at our 3rd trial of the same combination. We have a 1/4 teaspoon of calcium chloride, and we have 1/8 of a teaspoon of baking soda. Mix those two again. Same combination we've done twice. Initial temperature, 23 degrees. Here we go. Pop it in and stir and come up with our reaction. Now watch to see, make sure that's underneath the water. There we go. We got a nice reaction on that one. And we'll take a final temperature reading as soon as that's done fizzing. We still see evidence of a gas, which is bubbles. And we're going to go ahead and put that in. All right, the temperature is still rising. And we still have some bubbles forming. So we'll wait a second for that to finish. And then we'll take our final temperature. All right, that one is at 29 degrees. So 29 degrees. Still within our range, so I think we found our right combination. So there we go, within our range. Okay, so with that experiment and the first one, we had an open container. In other words, it's not closed to the environment, so the gas was allowed to escape. So now the question is, what would happen if we had a closed environment or a closed container? Let's find out.